Welcome and thank you for joining us today for Why Pay for Open Source Linux? Avoid the hidden costs of DIY. My name is Raleigh Gould and I'll be the moderator for today's event. Our featured speakers are Torsten Volk, Managing Research Director at EMA, and Dan Pesek, Manager of Market and Competitive Intelligence for Red Hat Enterprise Linux at Red Hat. With over 15 years of enterprise IT experience, Torsten helps end users and vendors leverage the opportunities presented by today's hybrid cloud and software-defined infrastructure environments in combination with advanced machine learning. Dan oversees analysis of primary and secondary research focused on customer requirements and competitor vendor offerings in the Linux market. The findings from the team's analysis are key to the ongoing development and promotion of RHEL as the leading enterprise Linux for commercial use cases. And before I hand things over to today's featured speakers, I wanted the audience to know that Dan and Torsten will be concluding today's presentation by taking your questions. Feel free to log them anytime by using the Q&A functionality. Also, you will be receiving a follow-up email from EMA with resources from today's event, so I hope you will check that email out. And now I'd like to go ahead and turn things over to our featured speakers.
Well, perfect. Let's do it. So why pay for open source Linux? That's a big question. Why should anybody pay for something that's free? I've taken, I believe it's about 2,000 questions from Stack Exchange, the Linux forum, and I've visualized them in a simple word pair, word correlation, topic map layout here. And they are all from 2022. And it basically shows you a little bit of what Linux admins are doing during the day. You know, what are their issues? What are the questions that they're asking on the Stack Exchange forum? And you can imagine on Slack and, you know, on the famous Red Hat forum, I'm sure they're asking similar questions. Even so on Red Hat, they probably don't have any issues, so no questions to ask. But so we can already see, you know, we see in hardware area, we see up there, we see a shell scripting area, the one in green there in the north of that chart, and to the right and the bottom we see container networking and file systems. Dan, is that roughly what you had in mind? What Linux admins do during their daily lives?
Yeah, exactly. We try to make sure that we're always, first and foremost, making sure that our operators feel safe and secure and have the tools they need to maintain uptime and performance. And so this pretty much, as far as I can tell, reflects what we're running into as far as what the operators are concerned with.
Okay, then let's get into the deck. So Linux can, in a nutshell, be a business factor. It can make a difference. It can help move the needle. And why can it do that? It can do that by enhancing the productivity of people so that they need to do less of the stuff you saw on the previous slide. Oh, by the way, the stuff behind me here is the same as you saw on that previous slide, but it is just in a gigantic tree map, in a categorized tree map. So I'll have that map in the deck in a moment. But the more we can basically get these developers and these DevOps guys to not do repetitive things and struggle with the Linux package manager and struggle with the things that we often see guys do on a daily basis, the more they can think about automating and about making stuff easier for developers. And developers, they can enjoy, if they don't have to deal with the Linux layer too much, they can enjoy the integration with containers and with their DevOps pipelines and the applications that they have. They, in general, can be more productive if Linux gets out of the way and just becomes something that's always there wherever they are. And yeah, at the bottom is the lower operational risk. If you have a solid operating system, by definition, you have a lower operational risk. You won't have anything exciting, hopefully, coming up that's related to your operating system. Dan, what's your take on all of that?
Well, absolutely agree. I mean, Linux can, be that layer that helps you, move faster, be more secure and maintain uptime. But it'll do that at any one point in time. But in order to keep Linux that way, in order to deliver on that capabilities, it helps to have, a workforce behind it that's keeping it up to date, up to speed, with the latest innovation and latest security, remediation capabilities, as well as integrating it with the tool sets and the automation that you need to run, effortless as possible.
And on the next slide, if you want to move there.
It helps to have, a workforce behind it that's keeping it up to date, up to speed, with the latest innovation and latest security, remediation capabilities, as well as integrating it with the tool sets and the automation that you need to run, effortless as possible.
And on the next slide, if you want to move there, kernel, and I just from the kernel website, from the Git, from the code repository, I just pasted that chart here of the quarterly commits, and you see they have about 20,000 or 21,000 code commits per quarter on the Linux kernel. That means that is a massive effort to keep that thing present and make it support everything and make it perform properly with all the different types of hardware and the integration, the system calls with containers and all of those low-level stuff that they have to do. And that is the same for all Linux distributions in general, but I'm sure Dan will tell us that that Red Hat manages to pick a kernel that makes the most sense at any given time, because the different versions, obviously, of these kernels available. And we see here at the top, basically, those are the differentiators of why you would pick one Linux over another. Starting at the top left, image management and provisioning. If it doesn't provision your application, then that is a problem. Then you will pick a version of Linux that does provision your application. And the same thing with the workload performance optimization. You want to see that your stuff runs on that copy of Linux properly, on that distribution of Linux properly, and performs properly. And there's different tools and different performance characteristics for different types of Linux. Then container management, we have container runtime, which is integrated with the kernel. Obviously, we have developer tools, monitoring, resiliency. All of those things are integrated with the kernel, and that's an example of the developer tools for Linux that we have here. And then, the application management. How are the application packaged? What is the package manager like? Does it cause issues with performance of some applications, which we've seen recently? And what are the tools, display manager, display server, that are currently available? Are you comfortable with those tools? Those are the main considerations. And obviously, Dan, another big thing is also the hardware support, the drivers, and the software support. If a vendor says, yes, but my my enterprise software is only supported on a certain Linux distribution, right?
Well, yeah, I mean, I think especially, speaking, from Red Hat's point of view, we spend an awful lot of manpower and resources and time and effort working with, as I said, the hardware providers and the software providers, ensuring that we actually can, make sure their applications and the drivers and the hardware all functions optimally on RHEL, because we spend an awful lot of time certifying and running through tests to make sure it gets there and stays that way. It's probably also worth noting that when it comes to the Linux kernel, you'll see that Red Hat, in combination with our mother company, I guess you call it, IBM, combined, we're typically in the top 10 or top 5 of kernel contributors every year for the past 5 or 6 years.
Do you know those guys down there?
I don't know the names, but I was noting that you have one there with Oracle called out, but you don't have any Red Hat people called out. But I'll figure it out.
The Oracle guy must have been clever. He probably put that in his name field.
But no, it goes back and forth depending on who's driving what upstream this year. Many times like Intel is the #1 kernel contributor because right they've got to get a bunch of hooks in there to run on their latest and greatest chipsets. So it changes, but we're commonly in the top, like I said, five or 10 corporate contributors, and a lot of the individuals are a lot of Red Hat badges are the people that are actually in the community upstream as well.
Yeah, and that's actually an interesting comment that you just made, Dan. The kernel contributions that you are making, or that Oracle is making, or that any of those guys are making, those are contributions that are relevant for those colorful boxes that are more up the stack, right? Like container management, like integration with your runtime, with Podman, for example, with developer tools, with all kinds of things. Like NVIDIA, I'm sure they make sure GPUs are supported in the various machine learning frameworks. So there's all kinds of interesting combinations between, or there's value. If you as a vendor contribute to the kernel, you will get that value also in the components that you sell commercially, maybe up there in those colorful boxes. So we'll talk about that a little more in a moment. Dan, if you want to go to the next slide. Yeah, just make it all visible. So what's interesting here is when we talk to people from the field, and they are not always Linux administrators, they are sometimes platform guys, they are sometimes DevOps guys. I always, I find it very interesting to get a quick take on Linux from a developer or from an SRE or from a DevOps guy, because they bring an interestingly unique perspective to Linux. It's not the old Linux anymore, where just the guys are in the data center and making sure everything runs fine and there's no horrible kernel issues and no horrible downtime or permission problems. And today, when we talk to people of all kinds of personas, we see a couple of different clusters of priorities they have for Linux, and security and cost are one big block of them still, right? If it's not secure, if it takes too long for a patch to come out when there's a vulnerability, then that is a problem. And that also, Dan, comes to the commercial aspect of Linux, right? Because you guys are on the hook if you take too long to get me I have a service level objective with you guys, I'm sure. And if you take too long to patch my vulnerability, I assume you're on the hook for that.
Oh yeah, a large part of what Red Hat does is monitor basically the worldwide security footprint, for Linux, and we're always on the lookout for vulnerabilities, and we have a dedicated team that responds to vulnerabilities as they occur. We have commitments to turn around CVE remediation patches as fast as we can, and probably something that people don't always know is we actually deliver the source code for all those patches upstream as soon as we've tested it on all our environments. Mm-hmm. So even the people that run some RHEL derivatives actually end up being able to take advantage of our security team as we commit to fixing vulnerabilities. But I think the other thing that you notice on this slide is you talk to various enterprises that are deploying Linux in the field. What you'll find is there's always this little bit of tug of war between people that want everything stable and never to change, and then people that want the latest and greatest. Mm-hmm. Being able to service both of those constituencies is very important to Red Hat, right? So we have things like 10-year life cycles for our releases of RHEL. We also have 2-year life cycle support for the minor releases of RHEL, and yet we also are constantly working upstream and with our hardware and software partners to make sure we're delivering the latest innovation, the latest APIs that people want out there in the commercial marketplace today.
Yeah. And the other areas that we are seeing in addition to security and cost are really sometimes special stuff, like we talk about machine learning, we see GPU support, and that's just one quote about GPU support. here. And what they often mean by that is that you can share a pool, or you can pool GPUs, and you can share those pools at the operating system level, and you can actually use them instead of getting gigantic bills from the rented ones at the hyperscalers. You can use what you already have, and that's true for other types of resources as well. It doesn't only have to be GPUs that you can pool and share inside of Linux. And yeah, and another big deal is the consistency aspect, and we'll get to that a little bit more. And for consistency, I also want that statelessness concept in there, because then that statelessness concept is why you guys at the time bought CoreOS as a basis for cloud native Linux, right? This is more, today we are focusing in this webinar more on Linux as such, but Linux is also the basis for cloud native, for Kubernetes, for container runtimes and all of those things, and consistency and statelessness of the operating system, that I can just add more at the edge, in the cloud, in the data center. That's also an important aspect, right? If I take one server out, all I'm losing is basically capacity. I'm not losing anything that is unique to that server.
Right. That's the other dichotomy we live in today, right? We've got folks that are running containers or processes that are, clusters or swarms or whatever you want to call them today, that have no problem with respinning a new instance of the OS and taking it down and bringing the new one up. Whereas then we have the other folks that are still running, you call them legacy apps, foundational apps, but mission critical apps that can't be shut down, right? And we have to do things like upgrade them on the fly, do live kernel patching and things like that, because they really indeed can't shut down. So again, Red Hat moves to make sure that we can service both of those requirements.
Okay, let's move to the next one here. So this is actually a slide very similar to the one that I have in my background, and it's just that basically the same, other than I cut out the programming language specific things and the cloud specific things. Like you see in my background here there's still Docker in there and Python and things like that. And here, this is more to give everybody an idea of, in more detail, what the challenges are for Linux administrators. And we see almost that left third of the screen is full of shell and bash and SSH scripting with a little layer of text processing. So literally, you can draw that line there where it's at the top left, where it's purple, between the purple and the green, and even shell is still scripting. So there's a lot of scripting going on in the Linux field, and a lot of those things are one-off scripts still. A lot of those things are just stuff to solve specific problems, where scripts are not necessarily parameterized, they're not necessarily centrally controlled, or GitOps is not really anywhere close to what those things are. So it's a lot of manual labor here. And then we see at the top right permissions, we see apt we see for installers, we see some kernel issues, but in general what we observe is that inside of all of those different issues, whether that's the security stuff with the permissions and what other security tables are there? OpenSSL, encryption. We see there all of those security relevant things, or whether it's the scripting, or whether it's the kernel related issues. They all have intersection points with more contemporary topics, like running Linux on Amazon, or running Docker together with Linux, and running cloud native apps and other apps side by side, so that Linux admins really have to become, or are becoming, a lot more versatile. So they have to cover a lot more ground, because they have to still cover all of this old stuff, in quotes, which is still as important often, and then they have to worry about, how can I make sure that I have the right setup here for my friends, the developers who need a proper, scale out architecture on Linux at the edge or on the Amazon cloud, and how does Docker run best? Dan, I mean, this chasm that is getting closed between cloud native and traditional enterprise application. Is that something that you're seeing in your daily life?
Of course, yeah. I mean, with with kind of the explosion of containers and cloud native development, getting ideally you try to make the administrator's job as easy as possible, but there's going to be a whole new set of skills in managing kube clusters and immutable images and things like that. That's going to have to come along. We do an awful lot to automate as much of that as we can inside things like OpenShift and with insights for OpenShift eventually. But yeah, it's going to be a growing skill set. I don't know if there's going to be a separate, kube cluster admin versus regular sysadmin, but it'll be an interesting thing to watch. It's going to be a valuable skill set. But the folks that can do it all, that know a little bit about how to do it all, are definitely going to be worth their weight in gold.
Yeah. And I think automation is critical here. And we had that on the Linux slide in the beginning. That's also how distributions differ, right? Where in the case of Red Hat, we have Ansible automation, right? In the case
Right.
of Ubuntu, we have Juju. In the case of I don't
Yeah,
want
and
to
I think
enumerate all of them right now, but yeah.
yeah, and I think that's also kind of the challenge is Linux may be Linux, but Linux distros are different. There's uniqueness to each one of them. No enterprise tends to have exactly one version of Linux or one distro of Linux. So the challenge gets a little bit more complex for the sysadmins because they have to figure out how to, I'm working on RHEL today, or I'm working on, CentOS, or I'm working on Ubuntu, or so trying to get folks to narrow down their choices of Linux, pick the ones that work best for them and in the cases that they need, makes more and more sense because complexity is real, and it's not going away. We're not going to be able to automate away all of it.
Yeah. It's funny. I just talked to a customer this morning, and they were talking about the packaging of one Linux distribution that I don't want to name now. And they had issues with their package manager that slowed down actual applications. And I said, I don't even understand how that is possible. I mean, I understand if it slows down maybe the initial installation, but why would it slow down application behavior? And we are looking into that, and they are looking into that right now. So there is a lot of, and I'm sure that's specific to that one distribution. I mean, I'm not sure, but I would imagine that it is because I haven't heard that complaint yet. So there's a lot of things that you have to solve for each and every Linux distribution, Dan. And if you go to the next slide, I like that picture for its serenity, and that stands a little bit for the serenity that you're supposed to get if you basically have one operating system that stretches across AWS, Azure, GCP, across bare metal, virtual machines, containers, serverless, across the good old traditional enterprise apps and the new cloud native apps, across the data center, the cloud, and the edge. Ideally, again, that would be the ideal state. You would have one image manager, one package manager, one everything manager for your entire Linux operating system layer, and performance would be predictable everywhere, right? You wouldn't say, ooh, maybe on Amazon Linux, the performance isn't as good, or I have an issues with certificates on Amazon Linux, but not on Google Linux. In the ideal case, this would take all of this away, but it's not realistic, right? Because when you spin up an Amazon machine, then you typically spin it up with Amazon Linux.
Well, you can certainly, and that's where a lot of people start. their cloud journey. You know,
Right.
they adopt a cloud and they pick the Linux that's easily available and the cheapest. But consistency, as you point out on the slide, is really the main goal of Red Hat and RHEL and in our other products, right? We're dedicated to having our customers have the same experience, whether it's on-prem, on bare metal or their virtualization environment, as well as the cloud or any of the clouds, right? So
Mhm.
we like to say we're dedicated to make sure your application runs wherever you want to run it, however you want to package it, and you have the same experience and the same support experience and the same security experience and common management tools and visualization tools across all of those footprints. That's to Red Hat. That's what our open hybrid cloud message is all about, right?
Mm.
It's for folks that are are always going to have at least 1 foot or a toe or two in the data center and 1 foot in a cloud and probably multiple clouds. Most people, if they're smart, are having looks at multiple clouds because they don't want to be locked into a single cloud vendor, or maybe another cloud provider has a different set of skills, a different set of expertise that you think are better serve one department versus another. But again, Open Hybrid Cloud from Red Hat is all about enabling you to run your favorite application where you want to, when you want to, and have the common experience across all the footprints.
Yeah. And it's often an enterprise software support issue as well, where the enterprise software vendor has it in their contract. It has to be a specific version of Linux that they're supporting that application on, right? And if you then
Right.
move it somewhere else, it may not be supported anymore.
Right. I mean, a key part of our day-to-day workload at Red Hat here is making sure that that the ISV applications are certified on our versions of RHEL across different cloud platforms. We have engineering relationships with all the cloud vendors to make sure the RHEL that shows up on Amazon is optimized as best it can for AWS. Same with Azure, same with Google. So we have dedicated engineering teams that make sure that you have that experience, you have the performance, you have the security, and you also have the secured ecosystem that can travel with you, whether it's hardware or software or APIs.
Yeah, yeah. So this whole code once, deploy anywhere paradigm that is so important for developers, right? Let's move to the next slide because speaking of developers, Dan, I love this slide, right? Because it shows the power of data. And all I did here was I went to the Stack Exchange Linux, the Stack Exchange, the Stack Overflow, which is also part of Stack Exchange, and the Server Fault forum. And it took all of the questions from 2022 until basically January to September 30th. And I sorted them by tag, by what the people tagged them as, right? This is no fancy machine learning algorithm here. This is just the tagging. And we got actually a very good and intuitive result, but it was also great because it shows that us analysts are not just talking high and mighty about containers and about DevOps and cloud native. You can actually see here the orange bar. The orange bar is with containers. So when you talk to developers, the containers are their most important Linux topic. And as we all know, containers are a part of Linux, and the Linux kernel has a significant impact on how well containers are working on Kubernetes or on Docker or on Podman, whatever runtime you have. And then also public cloud, the second largest orange bar here is public cloud Linux. And I have a slide to this as well, where we are seeing the different issues on public clouds, on the different types of Linux that they are using, which is, I find personally fascinating, because that shows that Linux is not only the kernel, the issues are fundamentally different often that you run into. Yeah, and then so our Linux admins, for them, networking is the biggest topic, and servers, and for our IT operators or platform operators in general, it's also networking and servers and security. Those are the biggest topics for those guys in general. Dan, any surprises on this deck here, on this slide here?
No, not really surprised, but as you can tell, because you've broken it down by admins, operators, and developers, you can see some of the challenges, someone like Red Hat has, and that we have to know how to talk to all of these personas, and we have to help them all out, right? So
without too much eye rolling, right? Without too
Right.
much, oh yeah, you are detached from reality. We are not building them for developers, but in reality, developers actually are consuming them through Kubernetes.
And some of
things
it, and
like that.
you have to have the staff and the team available to have these conversations and to do these diagnostics, right? Networking issues aren't easy. Security issues aren't easy. Kernel issues are, right? So you have to have that, Red Hat, because we're, over 20,000 employees now, and we're a global company backed up by IBM, we actually can bring the resources to bear to help customers figure out these, really intricate, complicated issues that they're trying to address.
Yeah. Yeah. And I'm just seeing the bars for automation are a little bit low, but that just means that people didn't have as many questions and issues with automation. But in other research, I find that people or Linux admins, namely, are not spending enough time on automation. That's another problem. But that comes down to who do you have in your organization who does Linux? Do you have enough so that they can not only keep the lights on, but also automate the systems, not just the deployment, but also day one and day two operations. And often it's the case that we see companies not having enough staff for that, and there's still too much manual scripting going on, which we saw on this very early slide about the importance of the shell and the bash, where people are doing a lot of ad hoc scripting. Dan, if you go to the next one, I'll finish mine off so that you still have some time for the Red Hat specific slides. So this is an interesting slide in that it shows basically what you saw before in the orange bars for the developers, right? It shows those orange bars, but split open into the topics that are underneath those orange bars. So we see Python developers here. What are their general Linux related issues? We can look into this a little bit. And again, those are the Stack Overflow in this case, tags and the hierarchy of tags. So we can drill from Python into a topic like security with OpenSSL or the Python package manager pip, what you can install on Linux with pip. Then you see Java environments, you see obviously a lot of bash scripting, but you also see a topic GPU down there, and you see GCC also basically compiling. So a lot of development and Python related topics at the top left. Interestingly enough, you also see Linux kernel issues. You can look at that in a little bit more detail, and you get the deck. You can, I believe, download that deck, and you see that in full resolution. So if you're interested in, what issues do developers have with the Linux kernel, then you can take a look at that in more detail. At the bottom, we see Git issues with Git, GitHub, GitLabs, Git Bash. So a whole variety of issues, and then next comes Azure specific issues, and we also have again enough AWS specific issues. And Dan, if you just move to the next slide, we can just take this as the introduction of your slides here, because what I wanted to get into is that difference, right, where you have seemingly the same problems on Amazon Linux, Azure Linux, and Oracle Linux, for example, here. I just mixed in Oracle instead of just doing the usual with Google. You could also have Google, you could have, any other additional Linux here. But what I did here, and I find this always fascinating, just random Linux questions that I put in here. And in this case, those are developer questions. So just what did they ask here? What issues did they have here? So for example, the first one, Amazon Linux 2, Ansible and Amazon Linux 2. How can I use Yum Yum module with Python 3? How can I basically use Yum with Python 3 on Amazon Linux too? So it's one question. On Azure Linux, we have different questions, but the answers, and that's the important thing, Dan, here, the answers to those questions, it may be a problem. The question may be a problem on all of those Linuxes, but the answer may be very specific, and often actually is very specific to one of those Linuxes, meaning that if you then move that same microservice or a traditional application to another Linux, so you move it from Azure to Amazon, then you may have that same issue again, but the solution may be a different one this time around. That is what is grinding down Linux administrators. And that's what that slide should show you. If you read, I'm not going to read through all of those, but if you read them, in their entirety, it shows you what there is to managing Linux on each of those platforms. And if you had one Linux distribution on all three of them, then I would imagine, and that's my experience, but then I would imagine that you see the issues being at least the same, right? And you can solve them once, and then you have them solved for all three clouds.
Right, and this kind of goes back to my statement about Red Hat's dedication to giving you the same experience on multiple clouds. What you run into, at least with the hyperscalers today, is having their own Linux is kind of a necessity. They have to have one to run a lot of the infrastructure, and they're also making it available. Why not to their customers? And that works great if you only want to be in that cloud forever and ever. But if you have thoughts about moving to another cloud, or either simultaneously or coincidentally, or also having the same environment on-prem, then again, you find yourself having to have sometimes the same question, but different answers and different remediations.
And it's even if it's a different software, but you have the same development team developing their next product, but next they develop it on Azure instead of on Oracle Linux, or they develop it on AWS. They with their new application, they use the same libraries again. They use a lot of the same stuff again, the same service mesh setup, whatever you have. And the answer may still be a different one in the new application. So even if you had the same operating system basis for different applications, but you have the same development teams, it would still make a significant difference in terms of day-to-day life. Dan, that is it. I just have a final slide, but we can do that at the very end if you want to move to yours here.
Sure, yeah. And I'll have to pick up the pace to get done today. But so folks, I'm Dan from Red Hat, and we often get the question, because RHEL and a subscription for Red Hat Enterprise Linux ends up being, it's not free in all cases. Although it is free, we did make it free for developers and enterprises, but still, and for mission critical workloads, we do charge a fee for a subscription, and so that's often raises the question. People say, well, I thought open source, was free. And open source is free to download, it's free to install, but there's some differences that happen and the value set and the value propositions between open source software that's supported and proprietary software that you're used to deploying. And we're going to walk through a couple of those key differences. Because at the end of the day, you're talking about deploying what we'll call an enterprise software, an enterprise environment that's going to run your business. Right? So your choices are pretty much come down to, building your own, buying it off the shelf from somebody, or deploying some open source community bits, or purchasing a subscription for enterprise open source software. And when we look at the different use cases, you end up with some pros and cons that are associated with each of one of these, right? So if you build it yourself, your acquisition cost is primarily your headcount, which is the same for your support, right? So you have to support your applications and your platforms with dedicated headcount. And then you also own all the ongoing maintenance. The pros are you have the ultimate flexibility and low initial out-of-pocket costs. But your cons are basically your productivity ends up being limited by the amount of headcount you have on hand. And this means you have resources that are working, maintaining your platforms, but not dedicated to running or enhancing your business. And the entire responsibility for maintenance and security falls on your IT staff. So you could buy proprietary, you could buy something off the shelf. Usually comes with a large initial fee plus a maintenance plan. Ongoing maintenance, you pay for support, but with some flavors of operating systems or applications, you actually have to pay for an upgrade for the next version. By the way, a little plug for Red Hat, because I'm from Red Hat. When you buy a subscription for RHEL, you basically pay the same every single year. And a subscription for RHEL gives you access to all versions of RHEL that are currently out there. So with the proprietary, you do have some great pros, right? You keep your developers focused on the business, enhancing your off-the-shelf applications, your application maintenance, for the primary components ends up being outsourced to a vendor. And security, a lot of time, large chunks of the security of the applications is supported by the ISV themselves. Once again, your innovation happens at the supplier's pace, right? So you're a little limited there. So the features that you want, the hardware that you want supported, all depends on how fast your supplier can deal with that for you, and how lucrative they see it in the market. And you also end up with limited flexibility and transparency on the functionality. So you don't get to see the source code. You don't get to see how it all works. And there's always the threat of a vendor lock-in for the proprietary. Now you can, download and deploy community bits, right? So you can get Linux for free. You can compile it yourself, but you end up with, so basically $0 cost, but you actually have to have the headcount to build it, deploy it, maintain it, and liaison with the community. Make sure that you're staying on top of all the latest features and fixes and remediation steps. And your ongoing maintenance basically ends up being done by the community, and hopefully if you're going to do this, some of your headcount are actually good members, members in good standing in the open source communities you care about. So you can end up with faster innovation because community software, open source communities can move pretty fast. You have a low cost of acquisition, low maintenance cost, depending on how stable and secure the environments are and how skillful your internal staff is. The cons are sometimes you can end up with some bleeding edge innovation that you didn't count on, right? Some of these projects move really fast and don't get to be fully tested at the level you'd want to see in a mission critical environment. The hardware companies, the software companies, and even some of the cloud entities don't always certify some of these open source bits for use in their environments. So basically, you're on your own. So the responsibility falls on you to keep your open source software maintained and secure and patched. Some packages are really popular, some of them aren't. Some of them you might find you're in a situation where you depend on some functionality that's critical to your mission critical workloads, but not really popularly supported in the open source community, and you end up with a talent vacuum in some of those areas.
Yeah, if it's not in the package manager, like there's a couple of distros with slow package managers availability. If it's not in the package manager and you have to do it yourself, that's a big problem, right?
Right. And then lastly, and this has become an issue more and more, the supply chain may not be secure. So where your bits come from and how can you prove that they came from a secure source is becoming more and more an issue as it's one facet of security. Where did your software come from? Who wrote it? Is there is there a back door in there somewhere that someone put in that you're not aware of? Who do you trust? And then who do you come after if there's a flaw? So that's why we're advocates of purchasing a subscription for an enterprise open source software. So we have a predictable cost model. It's annual fee, and you end up getting support from the vendor that builds and distributes the code and curates. When we talk about supply chain, curates the code. So you end up with the software is being developed and delivered by the same enterprise vendor. So you end up with the ability to collaborate with us, see the roadmap, adjust the roadmap, as well as work collaboratively with our engineers to come to problem resolution if we find a bug. But you also get to leverage the speed of the community, because everything we do is upstream, or ends up being upstream. So we contribute code as well as as manpower to make things hardened, tested, and certified, as well as support versions of RHEL for things like 10 years or so. And so you end up with a situation where you've kind of got the best of both worlds. You've got transparency, you've got the ability to use what you need, and then call somebody if you need help, as well as you're getting ongoing security fixes and bug fixes for the duration of your subscription.
Yeah, and as a vendor, you have every interest, even if you don't have a very tight SLA, but you have every interest in making customers happy by getting the next patch very quickly. And those are people that you pay, that you have on your payroll, that do the security patches in those cases, right? And it's basically in your interest to get this done as quickly as possible. And it's similar is true for an open community, but here, your business interest, your business is at stake. You got to do it quick.
Right. Absolutely. Because it's a subscription and we count on you renewing every year, and you won't, if you're not happy, you're not going to renew. And so in order to figure out if we were actually, making people's lives easier, we actually paid IDC to go. We've done it for like 3 years in a row, but we actually pay IDC to go out and interview a bunch of customers that have done it both ways, that have both Red Hat paid solutions, and they've also had unpaid alternatives. So just a few slides to highlight that. And what they found out is that they're actually seeing real upside into paying us. I mean, it sounds counterintuitive that you can actually save time and money by paying Red Hat for RHEL versus running an unpaid, self-supported, community-supported version of the OS. You end up with less staff required, less time to respond to bugs, less time to build new applications, and less time needed to deploy new features. This is all in a paper that's from IDC. And I gotta hit the other button. And it actually turns into dollars, right? And we've got organizations here that are saying that it actually their savings are coming from they actually can save money by deploying by saving time and also reducing unplanned outages, right? A lot of times when something goes haywire, you need to call somebody and figure out what's going on. It's nice to have someone to call and get that the outage fixed right away. We actually had customers reporting that they actually could buy less hardware, deploy less hardware, because they could achieve greater density safely in their virtualized environments too. And that's how that shows like over 3 years, people, if you look on this, this cost of infrastructure, dark blue bar at the bottom, right? This is actually hardware costs. People said they spent less money on hardware because they could do more with the existing hardware. And this is all versus running a paid environment versus an unpaid environment, self-supported environment. And just to put that into some text, we see some great reductions in costs, some great ROI, as well as making their infrastructure teams more efficient and even their developers more efficient, because the system is more stable and there's someone to call and ask for how to do best practices for configuring their developer environment and their test environment.
Yeah.
And now we get to turn it over to questions.
Let's do that.
Dan, I'll start with you, and Torsten, feel free to chime in. What do you see as the one operational highlight of RHEL compared to the rest of the pack?
The phrase Linux is Linux comes up very often, and in many ways, it is a true statement. So it's really about the vendor or the support organization behind the distro. So I would say the strongest point case to be made for RHEL is the fact that Red Hat is behind it. And we've seen a lot, right? We've been doing this for over 20 years on multiple hardware platforms, thousands of applications. And so the experience that we have, which has actually been hardwired into things like our Insights capability. So Insights is a utility that lets you, that monitors your system if you let it, tells you when you're patched, when you're not patched, whether you're configured for uptime, proper uptime and performance.
And you learn from other customers, right? It learns from other customers.
Right.
Too.
You're all that data that we take in, it's all encrypted and anonymized, but we actually, and then we compare that to all of our support cases, we develop these rules to constantly be able to help basically it's customers helping each other, whether they know it or not, through all of our experience being laid out in the Insights database. So like I said, it's all about, downloading a Linux and installing it is gonna work to some point. Any Linux can be made secure and performant. The problem is who does the work to keep it there? So at any point in time, it'll work great, but how do you keep it there? And how much are you going to spend of your own resources to do that?
Yeah. And for me, my part of the answer would really be the reduction of the versions of Linux and of the distributions of Linux in the organization is key to lowering operations cost, where if you could, like we showed before, if you can have the same Linux across clouds, or at least across all of your data center, across all of the edge locations, then you solve the same problem only once instead of once per Linux distribution often. That's
and to maintain the engineering level relationships you need with all of those cloud vendors, with all those hardware partners, with all those ISVs, right? That's the strength behind RHEL and Red Hat and all of our portfolio, right? You've got this company that's advocating for your requirements with all those vendors and all those partners.
Yeah, I mean, running all of the operating systems, every time there's an operating system issue, we call your number and choke your throat. That's certainly tempting for me. Not just personally. No, go ahead.
Yeah.
Great insights. Thank you both. The next question is, Microsoft just announced a managed version of K3s for Edge. Does Red Hat have something similar?
Yeah, so there's always this discussion about how do we do Edge, and what are the use cases for Edge, and where do you use containers or Kubernetes or just the operating system, and whether or not you want to do this through a cloud or not. Now, all the cloud vendors are going to have have an Edge platform and have a Kubernetes platform. So once again, I go to the open hybrid cloud definition that RHEL lives by, right? So we're definitely going to be in that space. You're definitely going to see us at KubeCon talk about our solutions for Edge, both containerized and non-containerized. And by the way, just a quick reminder, you can run and build and deploy small amounts of containers directly on RHEL. And I always advise people, if you're thinking about containers, you might want to start your journey with RHEL before you go full blown into re-architecting all your applications into a kube cluster, because that might not be what you need.
So you just run them directly on the runtime instead of on a scheduler. Yeah.
Right. So Microsoft is going to do that. Amazon's probably going to do that, but those environments are going to be limited to that cloud, right? So we're all about having the same experience regardless of the cloud. So you'll see us in that space, but again, it'll be cloud neutral.
Thank you. Let's take one final question. We are running a bunch of SAP products. Is there an advantage of RHEL over other distros?
Primarily these days for the latest generation of SAP infrastructure, SAP has chosen 2 vendors for Linux to certify their applications to, and that's RHEL, Red Hat Enterprise Linux, and of course SUSE's SLES product. So I think the reason you'd choose one over the other is that, here at Red, and we both have engineering people on the ground at SAP in Germany. We both have partnerships with many of the same financial services vendors and people around the world that depend on SAP platform. Again, I would say it goes to scale. Once again, we've got a pretty deep bench of personnel here that work with the hardware vendors, the cloud providers. And as SAP goes more and more to the cloud, you'll hear more and more about SAP and Red Hat's relationship, and that's just going to continue to strengthen. So I guess that's all I can say about that, because that's probably the only places we kind of run into SAP these days is in and around SUSE these days is around the SAP platforms.
Excellent. Thank you both for all that very insightful information. And I wanted to thank our audience for taking time out of your schedule to join us. You will be receiving a follow-up email that will include resources from today's event. So I hope you'll check that email out. And I hope we'll see you at a future EMA research webinar. Thank you again for joining us, and enjoy the rest of your day.